Hey guys, so welcome back for Tier 2 of linear optimization. Tier 2 you might also know as word problems, because this is the biggest thing in linear optimization is that there are word problems. So what we're going to do, and if you don't have this in front of you, you should get it, is this close reading protocol. Okay, this is going to be your savior for word problems. Okay. So have this out every time that you see a word problem. And I'm going to go through this more when we get to some of the application problems, but I'm going to go through the steps today. All right? So for linear optimization, on top of this, that's going to help you set up everything. Okay? There are some steps that we need to go through. Okay? And this is all about solving real-world optimization problems. So real-world stuff does not come in y equals mx plus b. You got to make it that way. So that is, we're trying to help you with this, and we're trying to help you with these application problems. Okay? So hopefully by the end of this video, you'll feel very comfortable with that. So, steps to linear optimization. Okay? The first step is to define the variables, okay? And it's right in here, okay? We're going to go through this process, and it's going to help you define the variables. Step 2, we're going to write a system of inequalities, okay? So that is the key. We've been practicing it for a while with equations. Now we're going to write some inequalities. We're going to have to graph the system of inequalities, just like Tier 1, okay? We then find the vertices, okay? So we find where it's shaded, okay? And we find the vertices for it. Then we write the linear function to be maximized or minimized, okay? This is what I'm calling the profit or the cost equation. Most times these are, we're trying to find the maximum profit that we have or the minimum cost, okay? So that's the biggest thing. It's profit or cost. And it's going to tell you what to maximize and what to minimize. And that's going to be where you're going to find the equation. Step 6, again back to that Tier 1. We're going to take these vertices from Step 4 and plug it back into that equation. And Step 7 is to select the greatest or the least result. So that's the key. If it says to maximize, we're going to choose the greatest. We want the max. If it asks you to minimize, we're going to choose the least. Okay? So you have to make sure that you're answering the question. Okay? And that is part of our 8 steps. All right? So let's go through this. Okay? And I'm going to follow this protocol. So the protocol tells me I have to read the entire problem once. Easy enough. Calculator company produces a scientific calculator and a graphing calculator. The long-term projections indicate an expected demand of at least 100 scientific calculators and 80 graphing calculators each day. Because limitations on production capacity, no more than 200 scientific and 170 graphing calculators can be made daily. To satisfy a shipping contract, a total of at least 200 calculators must be shipped each day. Each scientific calculator sold results in a $2 loss, but each graphing calculator produces a $5 profit. How many of each type should be made daily to maximize the net profits? Done. I just read it. Okay? I'm just reading it to understand. The second step is reread and identify what I'm trying to figure out. Okay? What is the problem or what it's asking me to do? Okay? I'm not doing anything else. I'm just identifying. Okay? So, calculator company produces scientific calculator. Okay, there's no question there. Okay, long-term projections indicate expected demand of at least 100 scientific and 80 graphing calculators each day. No question there. Because of the limitations on production capacity, no more than 200 scientific and 170 graphing calculators can be made daily. To satisfy a shipping contract, so there's no question there. Okay? these are just statements, okay? If each scientific calculator sold results in a $2 loss, but each graphing calculator produces a $5 profit, how many of each type should be made daily to maximize net profits? This is where I find my question, okay? Number one key, you look for the question mark, okay? But not all things have a question mark. Sometimes there's statements like find, okay, or calculate. Those are statements. Sometimes they're not with a question mark, so you gotta watch what they're looking for, okay? And what am I trying to figure out? How many of each kind, okay? Each kind of what, okay? And that's why we read the problem again. Each kind of calculator. All right? We're talking about calculators in this problem. That's the type of kinds, okay? And there's two types of kinds, okay? There's the scientific, and there's the graphic. Boom. Those are my two types, and that's what it's looking for, okay? Third step, identify any unknown words or phrases. And you might know all these words, and some people don't, okay? So the trick is sometimes there's a lot of words in here that you don't know, okay? Sometimes it's very simplistic. And you just have to ask questions. Is this relevant? Is this not? Okay? Some people might not know what production capacity is, okay? You just ask, okay? You don't want to get caught up on vocab, because a lot of times that's what holds people up from word problems, okay? So, by the way, production capacity is how much they can produce per day, okay? They can't just do unlimited stuff because there's a cap to what we can do. All right, so step 4, okay, has 2 parts. Identify the important information I need to be aware of, okay? Part A says, remove useless information in word problem sentences, all right? And part B says, remove useless information from tables, charts, or graphs. Well, we don't have a table, chart, or graph, but we can get rid of some useless information that I don't need. So a calculator company produces a scientific calculator and a graphing calculator. Okay, but they talk about that after. So I don't need that sentence. Long-term projections indicate an expected demand, well, of at least 100 scientific and 80 graphing calculators each day. Do I care that they're long-term predictions? Okay? It just says that I have an expected demand of at least 100 scientific and 80 graphing calculators each day. Because of limitations on production capacity, no more than 200 scientific and 170 graphing calculators can be made daily. Well, really, it tells me that no more than 200 scientific and 170 graphing calculators can be made daily. So I don't even need to know that. So that word that I might have already known isn't even relevant because no more than 200, okay, I'm done. To satisfy a shipping contract, I don't care about the shipping contract, okay? A total of at least 200 calculators must be shipped each day. Okay. If each scientific calculator sold results in a $2 loss, okay, that's important, but each graphing calculator produces a $5 profit, how many of each type should be made daily to maximize net profits? Okay. So that's all very important, okay? So I'm just going to reread this math problem. Okay, an expected demand of at least 100 scientific and 80 graphic calculators each day. Okay, statement, we're good. No more than 200 scientific and 170 graphic calculators can be made daily. Statement, we're good. A total of at least 200 calculators must be shipped each day. Statement, good. Okay? If each scientific calculator sold, that's a $2 loss, but each graphing calculator produces a $5 profit. How many of each type should be made daily to maximize net profits? Okay. So now we have to classify the problem and identify the procedure we're going to solve. We already know this is a linear optimization problem, and the procedure here is right here. Okay? So now we're going to go through those steps. Okay, the first step is to define the variables. Well, we're talking about two things, right? Right here. How many of each type? Well, we're talking about calculators. There's two types. Scientific, I'm going to call that X. Graphing, I'm going to call that Y. Okay? Boom, done. All right? So, check. I defined it. X is scientific, Y is graphing. All right. Write a system of inequalities. Well, for linear optimization, there's always two easy ones, okay? X, okay, we're never dealing with negative. People can't do negative stuff, right? So, X has to be greater than or equal to 0, because we got to produce some scientific stuff, and Y has to be greater than or equal to 0. We're dealing with something that's positive, right? So if you get a negative result, you did something wrong. Okay. So now we read the sentences again. An expected demand of at least 100 scientific. An expected demand of at least 100 scientific. Okay, scientific. Every time you see that word, X. Okay, so X has to be at least 100. So X has to be greater than or equal to 100. All right? And 80 graphing calculators each day. So graphing calculators has to be at least 80. So Y has to be greater than or equal to 80. All right. I got that information. Now, I'm going to kind of cross that out. I don't want to go back to it. All right. No more than 200 scientific. No more than 200. Okay, so I can produce at least 100, but I can't go over 200. So X has to be less than or equal to 200. All right. And 170 graphic calculators can be made daily. So that's my cap. That's my max. So Y has to be less than or equal to 170. All right. Now I got that information down. Okay, at least, a total of at least 200 calculators must be shipped each day. Calculators. Well, I have two different types, right? I have my scientific and my graphic. So when I combine them, when I put them together, they can't go, they have to be over 200, right? So when I combine them, every time I combine something in math, it's just addition. So I'm going to take my scientific, my X, and I'm going to take my graphing, Y, and I'm going to add them together, and I have to get at least 200. So this has to be greater than or equal to 200. I got awesome inequalities now, okay? Boom. I'm going to graph the system of inequalities. Okay, well, actually, let's go back to this. If a scientific calculator sold results in a $2 loss, but each graphing calculator produces a $5 profit, how to maximize the, well, is there anything that's equal to? No. So that is going to be a separate thing. That is going to be my profit equation later. All right? So I'm going to graph all of these. These equations here make these irrelevant. Okay? Those are more of the run-of-the-mill that I can always start with. So you can ignore those right now. I'm just going to graph these. Well, vertical, vertical. So I know my scientific over here is 100 vertical. Okay? But it's got to be less than 200 here. Okay? And it's somewhere in between these. All right? Y has to be between 80 and 170. So 60, 70, 80, okay, has to be here to 170 here, okay? So it's somewhere in here, okay? So now I have to graph this part. Well, I have to solve for y. So y is greater than or equal to negative x plus 200. Okay, well, that's my b. My slope is negative 1. So I'm going to plot, okay? And I'm just going to continue some points down so I know okay? And it's going to be like that, okay? So now, okay, I've graphed it, okay? Check. Find the vertices for the feasible region, okay? Well, the feasible region's in here, because it's got to be greater than this and in between all this stuff, okay? So all I'm going to do is find the vertices, all right? So they're here, 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 and here. So there's 5 of them, okay? So those 5 are, okay, 100, so it goes to the x, right? 100. Okay, 100, 170. This point right here. Okay. I then have 100 and 120 and 80. I then have 200 and 80. And I have 200 and 170. Okay? So, that's my feasible region. Okay, those are my vertices. Check. Now I have to write a linear function to be maximized or minimized. Okay? So they use these words in here, and they also use profit and cost. So, how do I maximize net profits? Well, scientific calculator sold results in a $2 loss, so I'm losing money, but graphing calculators produce a $5 profit. Okay, so if I'm losing money here, that 2's got to be negative. If I'm gaining money here, that's got to be positive. So, my maximizing equation, or my profit equation, okay, of x and y, is going to be negative 2x plus 5y. I'm losing money for my scientific, but I'm gaining money for my graphing. All right? So that is a check. Oop. That is a check. Now I'm going to substitute the coordinates of the vertices into the function. All right? So that just requires me to take all those points and plug them in. So for 200 and, I'll move this down, right? That's going to become negative 2 times 200 plus 5 times 170. All right? So that's going to result in
Give room.
when?
5:30.
Okay, I'll be done in a sec.
But if you need a room
I gotta finish this up and then I'm good.
Alright.
This is gonna be negative 400. Okay, this is gonna be 850. So my total profit is gonna be $400. $450 there. Okay, for this one, ooh, that doesn't want to come with me. 100, 100. Again, negative 2 times 100 plus 5 times 100. Okay, so that's going to end up being a $300 profit. All right. this, okay, is going to result in -2 times 100 plus 5 times 170. Okay, that's going to end up being a $650 profit. -240, 400, that's going to be a $160 profit. That's going to end up being 0. Okay? So now I've substituted it in, okay? And this is all my profits. All right? So does the system make sense? All right. Well, if I'm losing something from my scientific, does it make sense to produce more of my scientific or more of my graphing calculator? Well, if I'm making money on my graphic calculators and losing money on my scientific, I want to be more over here because I don't want as many scientific. All right? So now, all I have to do is go back and answer the problem. Okay? Select the greatest and least. Well, what do I want to do? How many of each type should be made daily to maximize net profits? I want to maximize. So I want the total. Okay? So I'm going to continue going back here. Okay, well, what's my maximum value here? Oh, my maximum value is actually right here. Okay? That's a $650 I make daily if I produce 100 scientific and 170 graphic. It's not the point now. And again, word problems, it's never the point. Okay? What does this X stand for? Okay? The maximum profits come from producing 100 scientific and 170 graphing calculators. Okay, so that is the statement. 100 scientific and 170 graphing calculators. That is going to maximize my profit. All right. So I have two other examples of this. One you're going to do by yourself. If you guys feel comfortable, stop the video now and don't watch this, and then you can follow along after. Okay. I'm just going to go through my second equation. All right.